Dear learners, welcome to my fourth session. Agenda of this session is in continuation of Industry 4.0 foundation lectures, what is IoT platform and what is IoT architecture. We will be trying to understand these topics, IoT platform and IoT architecture with few examples also. As I have discussed in my previous lecture, IoT is one of the key foundation technology for Industry 4.0, especially in the industry sector. Then we will be dwelling with how the connected products that the data is coming now in case of devices when they are deployed in plants and globally, then IoT is having a prime role connecting these devices, capturing the data, and then making available this data to the central systems. Those can be the cloud systems, those can be in-premises systems like data lake or transaction systems, and then creating or extracting the value from this data in form of some decision pointers. We may use a prescriptive, predictive analytics or prescriptive analytics or diagnostic analytics. That also we will be covering. That part of analytics I will be covering in the next lecture, but I will introduce the subject here. Then we will like to do in this session itself deep down of edge computing, why edge computing is required, what is the role of edge computing in overall IoT architecture. And we will end this lecture with few case studies now. As I have introduced in my second lecture that Industry 4.0 is having quite a few foundation technologies, and such as artificial intelligence, Internet of Things, connectivity, cloud computing, advanced analytics that we are going to discuss today in the next lecture, and quite a few other technologies like computer vision, augmented reality. I thought, first we will, as I mentioned, we will discuss the Internet of Things in detail and establish its importance and relevance and significance for Industry 4.0 kind of solutions. If you recollect this picture, which shows that, that how in a typical manufacturing, there is an interplay of technologies, there is interplay and connectivity of technologies for providing a wholesome Industry 4.0 solutions. One side, we need the technologies for connectivity, data transmissions, data capturing, and computational, and doing some initial computation, and where IoT is the prime technology, which we will be learning today again. And cloud computing also play a vital role in this whole schema. Then we have other technologies like human-machine interaction and AR, VR, robotics, and then analytics. I will be taking all these technologies in the later lectures. So our focus today is that to get little in-depth interpretations and knowledge about how IoT is facilitating connectivity one side, data capturing, and then providing the computational power to the Industry 4.0 architecture. If we see that a broad architecture of IoT, these pictures give us a quick view that broad architecture of IoT starts with the physical devices. The IoT device is connected, with the physical world. Like suppose I am connecting, turbine, or I am connecting a pump, then that is a physical device. Then to connect the physical device, we need the connectivity, a reliable connectivity, So that connectivity comes over here. It may be on the Wi-Fi, it may be on the local area network, or it may be on the terrestrial or terrestrial networks like GSM or some other networks. Then edge computing is the part of this architecture. Edge computing I am introducing here first time. Basically, edge computing is a important bridge between IoT and data storage and data capturing mechanism and processing mechanism of the cloud computing softwares. Edge computing play a very important role while connecting the thousands of IoT devices to the central processing unit, central processing systems like cloud computing. We will be studying this aspect also. Then it comes to data accumulation. Data accumulation is basically after the data has been processed, which has been captured from the devices. Now it requires some analysis, data analysis, and then we have to normalize this data. We have to see whether it is a secure data. If there any anomaly in this data, we have to harmonize this data, and then this data is being prepared for the advanced analytics. Advanced analytics like predictive analytics or prescriptive analytics or diagnostic analytics. Then the processing analytics. Basically, this also we will be touching in the second lecture. Is called IoT analytics. Analytics which belongs to the data which is being captured by IoT, we may consider in the category of IoT analytics. And finally, all this mechanism, all these efforts are for business applications. Like whatever data you are capturing through IoT, and then we are processing through edge computing, and then we are accumulating on the cloud system, and then we are doing some analysis through predictive analytics or whatever tools. Finally, it helps the business. It should be business problem. It should be business enabler. So that is what we will be seeing in case of few case studies also. So this is a 7-layer architecture of IoT, which is worth looking, and we will be dealing, except the business layer and component, we will be dealing in this lecture and the next lecture, all other layers. Now, if you see a typical IoT platform, we call it, it comprises of these 6 elements or 6 layers. IoT elements which we discussed in the last lectures, like sensors, actuators, gateways, connectivity, then connectivity options. It may be, as I mentioned earlier also in this lecture, it may be Wi-Fi, it may be wireless, it may be some network management, network infrastructure, So it involves not only connectivity, it involves the management also of the network. That's why the network management is also one of the key aspects of connectivity. Then today we will be studying, in this lecture we will be studying edge infrastructure. What is the edge infrastructure? What is the cloud platform? And then IoT analytics. And finally, all this work is being done for business applications and developing the advanced applications like digital twin, AR, VR, that we will be studying in the subsequent lectures. So if you see broadly, if we call all these technologies working together in a very integrated environment, this form a platform, IoT platform. It means if you like to implement IoT in any of the company and in any of the setting, you have to think about all these technologies and how you will use them, what you will require in these technologies, and and this has become one of the key aspects of IoT implementation, IoT execution. This is a data collection strategy which was suggested by Portal and James Happelman in 2005. Their article in HBR. And I already explained that that today the data is not only enterprise data. Data is coming from various sources. Data is coming from smart connected products. The smart connected products may be your smartphone, your smart devices, your smart, in a factory environment, all equipments which has been enabled with the smart devices like IoT. And then data is also coming from enterprise systems like sales data or transaction data. And then we also have the data on the social media, all external sources. So today that availability of the data and that their transmission of the data is from many, many sources. So we need a very different kind of data storage which can hold, which can store all kind of data, all format of data which we will be studying in the next lecture. And for that we require a different kind of setting, and we call it data lake. Conventional databases, RDBMS, are not capable of handling unstructured data in a volume. So data lake is required, and data lake become the pipe to multiple kind of applications, and one of the key application is analytics. So the analytics has been shown. So basically, if you see this diagram, this is a quite integrated diagram which is required to be implemented, which is required to be viewed in any of the manufacturing, any of the applications, or any of the solution which we are developing with the help of IoT and with the help of other advanced technologies like analytics. So this is something which is worth remembering, this picture, that data, when we say data, first of all, data is coming from which sources, what is the format of the data, and then data is being processed and stored where, what we are using this data for, analytics like that. And then finally, the business is beneficial of this data, business or customers, whatever. If you remember this picture, though it is a little busy picture, before I deal with the edge computing, I thought I'll explain this picture once again, where the edge computing come into this picture. So if you see this picture on the left hand side, a typical IoT device, and with the smart sensors has been shown. This is a IoT device where sensors are also part of the IoT device, and physical interaction which we have discussed a few minutes back. Now, once IoT send the data, sometimes data is quite voluminous. It is not just a few bytes or few characters. And not only one IoT device in case of manufacturing setting, or in case of smart city, we are implementing application. There will be thousands of street lights will be connected. Thousands of street lights will be connected. Some other kind of signals will be connected. So you need instead of sending the entire data to the cloud on the right hand side, you need an intermediate processing system. Intermediate processing system, we call it edge computing. Edge computing. So this requirement of edge computing was felt a few years back, and it has become quite generic whenever we try to implement IoT in an industrial setting kind of thing. Now, a typical picture of edge computing, how it is sitting in between of the devices, IoT devices, and between the cloud. This picture shows that connectivity. Like you can see that multiple IoT devices are connected. The data is being captured by edge computing system, edge computing device or system, and then a desired processing is being done. Suppose devices are sending, like suppose there is a camera, and this camera is sending pictures, and this is suppose information which is being sent in form of a data, discrete data. Now, camera and this discrete data has to be contextualized. It has to be connected. It has to be contextualized. Now, that work, that algorithm is residing in the edge computing system. This is a small, or I can say mini computer which is doing this processing, and finally it will contextualize that this picture belongs to this data, and then the processed data will be transferred or transmitted to the cloud system for further processing. So this is one example which I try to give. edge computing work as a bridge, between the data, because data from the thousands of hundreds of IoT devices are quite voluminous. If we allow to send the data to the cloud, it will become very busy, it will become very slow, and the cost will be huge. The cost will be huge because you will be paying a subscription cost to the cloud depending upon the volume of the data. So edge computing does both. First of all, it expedite our processing, it reduce the latency, and it also save the bandwidth, and then it economize the use of cloud, economize the use of the cloud. So that is what the first my explanation about the edge computing. Now these slides talk about that the various definitions in little more detail, like the modern manufacturing plant with authorized machines, conveyor belt, robot arms, and quality inspection system. If you consider these devices are sending data like vibration, temperature, pressure, and camera pictures. Now how IoT devices are generating, and with the help of actuators, the actuators and sensors, they are the two main main function of the IoT device, and then the data is being further processed, further dissipated, and further analyzed by the edge computing devices that I explained earlier, and then it is being captured and analyzed by the finished data, that the data which has been processed by edge computing, the output of that goes to the cloud computing system, cloud system. So this is some basic architecture. If we try to understand this concept with the help of an example, which I have also used in the earlier lecture, here we have seen that a turbine network is connected to the cloud. It is sending the status of the health of the turbine. It may be on the millisecond basis or second basis, and huge data is coming, and the cloud is analyzing this data, and sometimes suppose there are thousands of turbines, and millions of data bytes will be sent every second to the cloud. It may become the latency may be more, because cloud will have no capacity restriction, how much data it can process in a second or in a minute, like that. And then there may be a delay here in the processing, and the delay may cause some other problems, in case of the devices maintenance and device health status and retrievals, etc. So that is where the role of edge computing comes into. So this here I explain in this slide. What are the disadvantage and delays without edge devices in this scenario of the turbine. You can see that increased bandwidth and cost. We need the increased bandwidth of the network, and the cost also increases. And without edge computing network, round trip delays can range from tens of milliseconds. Once there is a delay, then the purpose may be lost. You will not be able to do the work which you are supposed to do, because it is called real-time basis. Instead of real-time, there will be delay, and there will be slow response. The role of edge computing is very important in this whole setting of IoT and cloud. This picture shows again in a same concept in a different manner. You can see that hundreds of devices, like and unless of your daily use things like car and robots and windmills and your computers and grids are being connected to the edge computing system, and they capture the data from this system, and they, as I said, contextualize, relate this data belongs to what, and they do the required processing. Then only after processed data is being sent for final processing to the cloud system. So question comes, what is the cloud system, which we will be learning in the next lecture in detail. Edge computing versus cloud, which I have already explained you. This picture again give you a little more detail. How the cloud computing and edge computing are interconnected, how they supplement to each other, how they economize the entire usage the computing power or bandwidth saving, like that. Now this picture I have made just to show a detailed technical architecture of cloud computing versus edge computing. So if you see in this picture, the IoT device, edge computing is doing the local processing, real-time action, Because why it is real-time access? Because edge computing is sitting next to the IoT devices. They are very near. The cloud may be in some other country, because there will be network delay. But no, edge computing will be very near to that equipments. Suppose we are connecting street lights of a town, a big town which has more than 10,000 street lights. The edge computing system will be in the street lights town only, and then it will be doing the desired processing, and the final output will be sent to the cloud for further processing and further signaling, etc. So that is one. Here there is another layer which we will be discussing in subsequent lecture called API, Application Program Interface. Whenever cloud is to be connected to the external world, external facilities, then API come into picture. Because cloud is having a dedicated function, but suppose it's required to be connected to the outside world. We call it a cloud ecosystem. Then API programming interface come into picture, which we will be discussing later on. Because we have to see the entire this diagram in totality. Without API, the cloud will not exist for a larger business. Larger business, which when business is having multi-location kind of applications. This is again a little more clear picture that how the edge computing layers exist, vice versa with cloud layer. We will not say that, like in the right hand side, I have explained here, the low latency allows manufacturing system to operate in real time. Edge computing helps to provide the low latency of the network data. Low latency allows manufacturing system to operate in real time, improving responsiveness, reduce downtime, enhancing safety, and optimize production process. So edge computing has to be understood not only as a technology, but as a business technology, because it helps achieve the cost benefits, it achieves the speed, it achieves the performance, many other advantages are there. Now I have a few examples which I feel that will help further understand this whole concept of IoT devices, how IoT devices are connected to the field equipments, and then how they are transmitting data on a real-time basis. This is a picture of a manufacturing plant. One side we have real-time production dashboard. One side we have data from the warehouse, production and supply chain optimization. This data we have equipment. This is transmitting the data from production and supply chain optimization systems, and then it is being received by condition-based monitoring, because we want in this plant the condition-based maintenance. Suppose any of the equipment is falling or failing to perform, then condition-based maintenance has to be done in the workshop, in a workshop. So this is basically once it transmits the data here, transmit the condition here, then the action is being taken by that technician. This is another example of IoT used in the retail. You can see that here there is a first inventory for optimization, then here customer tracking. Third is that we want to do timely personalized promotions, and then we want to do optimization of the use of the products which has been displayed in the stores, and then also we want to have the customers when they want to check out, they should check out automatically. If they are taking out any goods, they need not to swap, automatically the money will be deducted from their account. The way sometimes we do in the check post, the check post. So when your car passes to the check post, the money is deducted from your account. So like that, this system is being, these kind of systems are being now actualized, being developed, is being provided, with the help of IoT kind of infrastructure, The next is a very interesting example of connected car. You see this picture. This is a connected car or driverless car. I will break this into two parts. They are connected car applications which are not driverless, where companies are providing some maintenance and downtime services, like Tata Motors has implemented smart vehicle application, where they track that vehicle, they track the vehicle. In any vehicle is having a breakdown, automatically the system trigger that there is a breakdown in this vehicle, and then the services come into the play. Services start working. They will automatically call this driver. They will contact this. They will locate that where is the vehicle right now, and the service will start helping to that vehicle which is right now in the problem, or it requires some repair. How it is possible? How it is possible? This picture shows all those kind of connectivities. A schematic diagram, I will say, will help us to connect. Here, this again, this car is connected to the V2 communication traffic flow optimization. This is a system, which this kind of application require for connectivity of this car. So, on the left hand side, I have explained you here the role of IoT in the smart vehicles. What makes a vehicle smart? That is because incorporation of multiple sensors and connectivity to the network, it makes the vehicle smart. Advantage of the IoT enabled smart vehicles: enhance safety through real-time hazardous detection, reduce accident by monitoring driver status, predictive maintenance, reducing downtime and repair. So, this is one kind of application which is coming, which is being implemented by many companies in our country. In US, it is very common that your car is always connected to the service station. So, friends, I thought with this explanation, you would have been clear about that the use of IoT in context of the outside world, in context of edge computing, and what IoT, if you like to use IoT in a more robust and industry application, you require this kind of technical architecture, technical application, so that you can extract the full value of IoT. Thank you very much.